Okay, so by request, here is a video key to the practice problems from this week. All right, so we'll start with question 2. And in part A, it says, what is the probability that one randomly selected amount, so that's going to be X, will be more than 3,000? So now we need to convert from X to Z. And to do that, we take 3,000 minus the mean, which in this problem is 2307. And we divide that by the standard deviation, which they say is 690. And we go pull up a calculator to do that. We get 3,000 minus 2307 and divide that by 690. And that's 1.0043. And now to find that probability, we need to go over to StatCrunch. Pull up the normal calculator. And we said that's 1.0043 greater than. So we go to greater than 1.0043 and compute, and that's our answer. So the probability is 0.1576, and you could copy and paste that into your homework. All right, so that's problem 1A. 1B says find the probability that a sample of 25 donors will have a mean amount less than 2,500. Okay, so that's part A. Part B, probability that the mean will be greater than, or be less than, less than 2,500. This is one of those where this is a central limit theorem problem because it's asking for the probability related to the sample mean. So I'm going to come over here and say, we said mu sub x bar is just what mu is, which is, in this case, 2307. And sigma sub x bar is sigma, which is 690, over the square root of the sample size, which is 25. So for this problem, we've got 690 over the square root of 25, so 138. So back up here, we do 2,500 minus mu sub x bar over sigma sub x bar. And 2,500 minus 2307 divided by 138 is 1.3986. And so now we go over to StatCrunch. Probability Z less than 1.3986. Change this to less than, and our answer is 0.9190. All right, so that's part B. Part C, two values that make up the middle 90% of all donations. For this one, we have to start with StatCrunch. So we're looking for the middle 90%. So we go between, so middle 0.9, hit compute. This tells us that our two values are plus and minus 1.6449. So over here we start with plus or minus 1.6449. And remember the formula z equals x minus mu over sigma, we can rewrite that, rearrange that, and where it's solved for x. And if we do that, we get z times sigma plus mu. So we're going to need to plug in to this second formula because what we have are two values of z. So we get x equals plus or minus 1.6449 times sigma, which is 690, plus mu, which is 2307. And we're going to get two values there. We're going to get 1.6449 negative times 690 plus 2307. So that's 1172.019. And go ahead and write that down. 1172.019. And the other one is going to be the same thing except with the positive. 690 plus 2307. And so the other answer is 3441.981. All right, so that is part A, or that's question 2, parts A, B, and C. All right, so now moving on to question 3. Question 3, very similar. Part A. The probability that a randomly selected, so that's one randomly selected iPhone battery 4 lasts between 12 and 14 hours. So this is a between, so that means we got the less than, the less than. So now we convert to z by subtracting the mean, and the mean here is 14.55. And we divide by the standard deviation of 2. That makes that a z in the middle, and then we do the same thing up on the upper side. 14 minus 14.55 divided by 2. And that's the probability that z is between these two values. So 12 minus 14.55 divided by 2. So that's 1.275. This mouse pen is a little bit challenging to write with. Less than z, less than that's negative 0.275. And we just go over to StatCrunch and type those values in. So negative 0.275 and negative 1.275. And we get an answer of 0.2905. All right, so that's 3A. 3B says find the 80th percentile. To get the 80th percentile, we first have to go over to StatCrunch and get the 80th percentile of x. So we're going to type in going to the standard one first. So I change the probability to 0.8. And that tells us that the 80th percentile for z is 0.8416. So we start over here with 0.8416.